Hello, and welcome back to the Cosmic Companion. This week we are joined by Dr. Andrea Dupree, Senior Astrophysicist with the Center for Astrophysics. She recently carried out a study showing why the red supergiant star Betelgeuse recently dimmed, a sight seen by millions of amateur astronomers worldwide. We also look at how the development of life on Earth may have been shaped by a nearby supernova explosion, and we take a look at a new study suggesting the Sun may have once had a stellar companion with whom it was born billions of years ago. Meanwhile, NASA charges batteries on the first helicopter ever headed to another planet. For decades, the causes of one of the 5 great extinctions in the history of Earth, the Devonian period extinction, remained a mystery. Now, new research suggests the explosion of a red giant star 65 light-years from Earth may have depleted the ozone layer on our planet at that time, wiping out much of the life on Earth. Such an event would have bathed the planet in high-energy electromagnetic radiation, followed by 1,000 centuries of bombardment by energetic cosmic rays, altering life on our world forever. On September 1st, we'll talk to Dr. Brian Fields of the University of Illinois, who headed this study. Make sure to tune in next week for this informative, fun interview. A twin star of the Sun formed billions of years ago as the solar system took shape might help explain movements of bodies at the outer reaches of our family of planets, researchers suggest. Astronomers from the Center for Astrophysics believe that if a 9th planet were to be discovered beyond the orbit of Pluto, its movements could help us better understand how the Sun and our planetary neighborhood formed billions of years in the past. Batteries aboard the Ingenuity Mars helicopter have been successfully charged as the revolutionary vehicle heads to the Red Planet with the Mars 2020 mission. NASA engineers have also carried out the first of several course corrections needed to guide the robotic explorer with its interplanetary helicopter to a safe landing on the Red Planet. This tiny drone-like aerial vehicle is designed to carry out the first powered flight on another world in the spring of 2021. The Ingenuity Mars helicopter, together with the Perseverance rover, will arrive at Mars in February. This week, we are joined by Dr. Andrea Dupree, astrophysicist from the Center for Astrophysics, talking about her recent findings unraveling the mystery of the recent dimming of Betelgeuse. This week on Astronomy News, the Cosmic Companion, we're happy to be joined by Dr. Andrea Dupree. She is a senior astrophysicist at the Center for Astrophysics and has recently discovered some interesting things about Betelgeuse. Welcome to the show, Andrea.
Thank you.
So,
glad to be here.
Thank you. So over the last, from about September of 2019 up through the first couple of months of this year, millions of people around the world noticed that the star Betelgeuse was dimming quite significantly. Can you tell us a little bit about what happened?
Well, it was a little frightening because we did not expect it. And when you looked at the constellation in January and February, it looked wrong. I mean, really wrong. We all know what Betelgeuse should look like. We all know what the constellation Orion should look like. And if you looked at the shoulder, if you looked at the right shoulder of Orion, something was missing. As a matter of fact, we were all at the American Astronomical Society in Honolulu and went out to look at night, and the world was turned upside down. It was just very strange and very, very surprising. Now we know that Betelgeuse has a 420-day period, which is sort of a period in light variation, which is caused in part by the pulsation. The star is pulsating. It's moving, the surface of the star is moving in and out, much like a Cepheid star or something. And so we expect the light to vary. However, and everything was fine until, it was about the end of November when instead of stopping and turning around again in brightness, it just kept getting dimmer and getting dimmer. And then we took a picture of it with a equipment called Sphere down at the European Southern Observatory in Chile. And part of the star was missing. The whole southern part of the star was dark. Usually the star, we'd imaged it before, looks like a circle. It's like a sphere. But the bottom part was missing. Very, very puzzling. Fortunately, this year I had started a Hubble program with the Hubble Space Telescope to observe Betelgeuse, because we're trying to understand how stars like Betelgeuse lose material. We know that they're losing material all the time in a stellar wind. And we wanted to find out, where did it come from and how fast is it and does it vary and things like that. So we started monitoring the star with the Hubble Space Telescope. And we measured it about 6 times during 2019. And everything was fine in January and March. Look like usual. We've looked at it before, and the wonderful thing about Hubble is that we have a aperture where we can let the light in to obtain a spectrum. We want a spectrum because that tells us, when we break the light up into its colors, that tells us what it's made of. It tells us how fast it's moving. It tells us what the temperature is and what the density is. So getting a spectrum from a star is extremely valuable. Pictures are nice, but spectra are more valuable, in my opinion. And with Hubble, we could not only get a spectrum, but we could get a spectrum from different parts of the star. Remember, Betelgeuse is big. I mean, Betelgeuse is really big. It's a supergiant. And if we put Betelgeuse at the center of the solar system, the surface, the part that you see, like the disk of the sun, the surface would extend out to the orbit of Jupiter. And the ultraviolet chromosphere, which is the atmosphere on top of the surface, would be even further. We'd be going beyond Pluto. We'd be way, way, way out. So the wonderful thing about Hubble is that we can point to different parts of the star, actually to 8 parts of the star. We would move the telescope from the north to the south, and take a spectrum at 8 different positions. And when we looked at the data that we got at the end of the year, in September, October, and November, there was just this huge hot spot on the southern part of the star. And it was moving out, and it was hot, and it was denser than it had been before, and denser than other parts of the star. So we think that what we saw was the material that moved away from the star, moved further out through the atmosphere, where it gets cooler. And once this hot gas, when we see the gas had temperatures of perhaps 20,000 degrees. But when it gets out further, it gets much cooler, a few thousand degrees, perhaps a few hundred degrees. And then all this hot gas condenses and makes basically dust. And we think that that's what happened, that this hot gas went out, it cooled down over the southern part of the star, and I see it over your shoulder in the background. And that created the dust, just like soot in the atmosphere, that then blocked the bottom of the star. And we think that's what happened. And then it got worse and worse and worse until it was the first week in February, from the 6th through the 13th, when it was the dimmest it's ever been. And this is really historic because astronomers started looking at Betelgeuse back in about 1840. And this was Sir John Herschel when he started making visual estimates of the star. And it has never been as faint as it was last February. So it's a really unique historic event that happened. So it's pretty exciting.
Wow. So now how is, now of course, now in other stars, including our sun, there's all sorts of convection currents and movement of material in and near the surface. So how is that different from what recently happened on Betelgeuse?
Sun, the sun is the only star other than Betelgeuse where we can look at the surface in detail. But the sun, remember, is a small star. Betelgeuse is 1,000 times bigger than the sun. It's really big. And the sun has very strong magnetic fields. So much of what we see is magnetic activity and the interaction and restructuring of magnetic fields. For instance, the coronal mass ejections. After flares, when the magnetic fields reconfigure, suddenly the sun will throw out a lot of material from the corona very rapidly. We don't believe that Betelgeuse has that strong a magnetic field. It's large, it's less dense, it has lower gravity. It means it's easier for things to move away from the star. And it also has a very different surface from the sun. The sun has very small convection cells. They may be the size of Texas. The size of the convection cells on Betelgeuse are to 10,000 times larger, even larger. It may be a quarter of the star. And we know that. We've seen this with Hubble. We've observed Betelgeuse with Hubble in the ultraviolet. We've taken pictures, and we find these great convective cells on the surface that are hotter, that vary, that come and go. We don't know if there's any particular period, but we know that that's what's there. And we think what happened this time is that not only did we see a hot cell on the surface, but we were measuring the motion of the photosphere of the lower surface of the star using robotic telescopes in the Canary Islands that automatically take a spectrum of the star every night, and they've been doing it for a long time. And we know that during its pulsation cycle, this is the 400-day pulsation cycle that we spoke about, that the star was moving out. The surface of the star, starting in about early spring in 2019, it was time for it to move out, and it was moving out. And so just around the end of December, February, it started turning around and going back in again. So we think that there was just a magical mixing of this big convective cell plus this outward motion that caused the material to be thrown off and escape the surface of the star. So what's happening now, I don't know. You know, when the Earth moves around the sun, sometimes the sun gets in the way of Betelgeuse. And that happens usually around early April, mid-April. And so from the Earth, we can't see the star anymore. And you wonder, what's going on? Well, I realized that there's a satellite called Stereo that follows the Earth in the Earth's orbit. And it follows the Earth by about 2.5 months. And so what that means is that when it's June on Earth and we can't see Betelgeuse, my goodness, it's only mid-March to this satellite. And so I called up these folks at Stereo and I said, could we look at Betelgeuse? Because they have a very wonderful camera. It's a wide CCD. It covers 70 degrees. I mean, that's almost like a right angle, big section of the sky. And the nice thing about that is that then we have other stars to compare it to, because we can see how bright is Betelgeuse, and then we can look at other stars to see how bright, we know how bright they are, and we can measure them and compare them to Betelgeuse. So I convinced them that this would be a good thing to do, and they were wonderful. We had to roll the satellite, and we were out of contact with Earth for about 2 hours every time this was done, because the antennae no longer point in the right direction, so we can't get the signal back. So they rolled the satellite over. they took a sequence of about 15 exposures and then rolled it back and then read it down in a special format for us. Normally, they bin together the pixels to make the transmission smaller and faster. But for us, we didn't want that because Betelgeuse is bright and it might end up saturating, just as a photograph can be saturated and be black. So it all worked out perfectly. And Betelgeuse is getting fainter. and it's too soon to get fainter. This isn't what it should be doing right now. So we have to see what's happening. I have some really late breaking news, which 2 nights ago, it's now possible to see it from Earth. And we have a very wonderful observer who called and emailed and said he saw it in the morning in Texas. He's got a good measurement, and it may have sort of standing still right now, but still fainter. So we'll see. We're fingers crossed. Whether this is happening again, I don't know. We also have another Hubble observation. Hubble can visit the star again sometime in the next 2 weeks. So it's in the schedule. And when those data come back, I sure am going to run and grab them really quickly. Let's see what we see.
So fine. So of course, as you know, being a red supergiant star, at some point, Betelgeuse is going to explode as a supernova. And of course, it's possible it could even be a daytime star here when that happens. But do we have any idea, or should we have some idea, but do we expect a similar sort of dimming to occur just prior to a supernova?
Will be a supernova. It will be a supernova. When it will be a supernova, I'm not making any bets. I'm not promising. Actually, there was a lot of chatter on social media. If you look, we looked last February, and I remember someone even wrote, "My calculations say it's going to explode tonight." And then he wrote #hide. Now, I'm not sure where you hide. I'm not sure whether you go under the desk or in your cellar. So, yeah, it definitely will be a supernova. And see, that's another interesting thing because, we don't know how a star like that is going to behave right before it goes supernova. People have gone back through historical images of various things, and sure, they might say a year before it did this or 6 months before it did this, but the night before?
2 hours before?
2 hours before?
Right.
We don't know. What's also interesting is that when the Vera Rubin Observatory starts taking images, and they're going to take many images of certain fields very frequently, we may get a clue to that. And also, too, we're trying, it turns out that the Harvard plate collection is very extensive, and it was just recently digitized, and it has images of the Large Magellanic Cloud. Now, 1987A was in the Large Magellanic Cloud, and the fellow who's doing it says he thinks he's got enough data so that we can get a much closer timeline. So he's working on that, and I keep saying, everyone asks me, when is Betelgeuse going to go explode? And so we'd love some insight. Of course, remember that the 1987A was a blue supergiant. It was on a blue loop. So it's not exactly the same as Betelgeuse. And to be fair, maybe it would behave differently from the way Betelgeuse behaves. We don't know. We don't really know. And predictions are very hard to make. So we'll just keep our fingers crossed, and maybe there'll be something exciting.
So are there people now who are keeping a constant eye on Betelgeuse, or is it more of a haphazard?
Oh, certainly. Well, the American Association of Variable Star Observers has it and on its list, and there are many people making observations every night when it's accessible, which is generally from about late August to early mid-ish April. And then it goes too close to the sun to see. So yes, we are taking making visual estimates of its brightness, because remember, it's bright. I mean, you can do this with your naked eye. I mean, as I said, when we looked at Betelgeuse in February, the whole constellation of Orion didn't look the way it should.
I have to admit, on New Year's Eve, I watched Betelgeuse for quite a while, just figuring the chances of it actually being seen exploding on New Year's Eve were pretty small, but if it happened, I didn't want to miss it.
I'm sorry, I can't pick a date for you. I don't know.
So finally, what sort of future technologies and instruments might we use to learn more about Betelgeuse?
Well, one thing I'd love to do is to go and look at it with ALMA. ALMA, is the radio interferometer ring of radio telescopes in Chile, and you can image the far out parts and the molecules in the far outer part of the atmosphere with it. And by looking at those molecules, you can look at motions in the atmosphere. And we're hoping that we will find signatures of the material that went off from the southeast quadrant that we saw with Hubble, that we saw with the cloud, and presumably that material will then progress outwards and become even cooler and produce molecular emission or absorption features. So we like to keep looking. We have another year to observe it with the Hubble Space Telescope. And I must confess, I'm thinking about applying again to see if we can get more time, because who knows what's going to happen. And this has certainly been very exciting.
Super. Well, thank you very much. It was wonderful to have you on the show.
Thank you. It's been great fun. And keep an eye on Betelgeuse. You never know.
You never know. And that was Dr. Andrea Dupree from the Center for Astrophysics. Next week on Astronomy News with the Cosmic Companion, we'll be joined by Dr. Brian Fields of the University of Illinois. We'll discuss his work tying an ancient supernova to the Devonian period extinction, one of the greatest extinction events in history. Subscribe to this channel and never miss an episode. Please stay safe, stay healthy, and keep your wonder alive. If you enjoyed this episode of The Cosmic Companion, please download and share the episode on YouTube, Facebook video, or on any major podcast provider. For more details on space and astronomy news, please visit thecosmiccompanion.com or thecosmiccompanion.net.